Welcome, lesson 3-14. Today, before we get going, the first thing I want you to do, because we're going to be looking at constructing graphs of polar functions, I have created something on Desmos I want you to use. What I want you to do is go to your Google Classroom. Once you log in, I want you to go to your classwork, find Unit 3, scroll down to Unit 3. This is lesson 3-14. Find that, and within there, you'll see an attachment that says Polar Graphs Desmos. I want you to click that open. We're going to use that today. Make sure you have that graph going. I'll let you pause your video to get there. It should load with something similar to mine. Make sure you have this graph open. We will use this all throughout today's class period to really help us out. So go ahead and do that now. Make sure you go to Google Classroom, 3-14. You'll see a Polar Graphs attachment. Hopefully that was enough time for everybody to get to this graph. Again, it was Google Classroom, 3-14 is the folder. You look for Polar Graphs, bar, Desmos, you click it, it opens up this. Let me explain what you're looking at. Last class we did polar function or polar graphs, and we also did rectangular graphs. This is the same way. On the left side, notice the title in blue, it says polar graphs of a function. On the right, it's going to be the rectangular. Last class, we only did points. Today, we're dealing with a whole graph. How the point system worked. Do you remember on rectangular how I said it was a locked system? What did I mean by locked system?
Yeah.
Doesn't move. The y-axis over here, it's positive when you go up, it's negative when you go down. That never changes. For the x-axis, it's positive when you go right, it's negative when you go left. X is negative when you go left. Okay, the polar system was not locked. Do you remember what it was that changed?
The axis.
The polar axis. Okay, so let me show you the first thing, how this graph works. Take this slider on the left side. Take your slider. As you start to move it, you'll notice something changes on the polar graph that does not change on the rectangular graph. On the polar graph, you'll see this gray line rotating. That represents the polar axis spinning. Does that make sense to you? On the rectangular, it doesn't change because it's locked in place. The graph sure moves, but the polar axis moves, it rotates on the left graph. On the right, you won't see any axes moving. That's the first thing I want you to notice. And the second is this. Do these two graphs look exactly the same? Believe it or not, they're the same equation. But in polar, they look quite a bit different than they do in rectangular. In rectangular, this is just a good old-fashioned wave. In polar, you're going to learn this is called a limacon. It's a French word. I'm going to call it limacon today. That's a limacon. But here's what I want you to notice. When I graph a polar function, I'm going to move this to, it's easier if you look on the top. I'm going to track it to pi over 4. I'm going to move my point to where this tracks to pi over 4. You see this gray axis right here? My graph, the point of purple, will represent where the graph is at any point in time. Has to be on that axis, which means if it was a positive value, it would be towards pi over 4. Don't remember this from last class? Positive is when you go towards the angle. Negative is when you go away from it. Is this purple point in the place of a positive R value or a negative R value if it's away from the angle? It's negative. And you can see over here, it's a negative 0.8. Now I'm going to track it along, and I'm going to go now to 7 pi over 12. I tracked it up to 7 pi over 12. Now, here's my purple point. What would you tell me about my purple point? Is it a positive R value or negative R value? Positive. Why is it positive? It's going towards the angle. Now, how does that compare with rectangular? Well, it would be if it's above the x-axis or below. You see how this is, we said it was positive? It's positive because this is above the x-axis. Okay, last thing I'm going to show you before we get into it. What happens when I'm at a 0 on a rectangular graph? Let's see how that compares on a polar graph. What happens when I'm at a 0? There it is. I'm at a 0 on the rectangular. How does that correspond on the polar? It's the origin. Very good. That's a very big key thing today. Anytime we hit the x-axis on a rectangular graph, that corresponds to hitting the origin on the polar graph. They call it the pole. It hits the pole whenever you hit a 0. So a 0 becomes an intersection with the pole. Make sense? Okay, hopefully you catch that today. This maximum value, how tall is it over here? 6. This is a maximum value of 6, but here, look, it's not the same height. Do you know why? This 6 is still considered 6. It's because in polar, you don't go up and down, you don't go left and right, you rotate and you look at the largest value from the pole. It happens at pi. You see how that's at pi right here? At pi, this would be the maximum. Guess how many circles this is out? If this is up at 6, guess how many circles this is over here? Well, it's zoomed a little different. This is the circle 5. This would be at 6. What I'm trying to say is it's at 6. You can look over here, it'll tell you. That's at a value of 6. So with that, we're going to get started. That's your introduction. Let's go over to your note packet now.